Hi, I'm Andrew Jagnarain, and I will be teaching you about geodatabases. Feel free to pause or rewind this video at any point for clarification. First of all, what is a geodatabase? Geodatabases manage coverages, shapefiles, and tables inside of a database management system. They're designed to store, query, and manipulate geographic information and spatial data. These databases are optimized to store and query data related to objects in space, including points, lines, and polygons. So why do we use geodatabases? The architecture allows multiple users to view, edit, and query the database without conflict at the same time. Each entry in the geodatabase can hold multiple data types. This can be very useful in multiple applications. Listed below are several features of geodatabases. They are particularly useful in construction applications and transportation planning. Listed below are several types of data commonly found in a geodatabase. In the next few slides, I'm going to be going through an example in which several of these are used. At each geographic location, multiple attributes can be stored, including attribute data, geographic features, satellite or aerial images, CAD data, surface modeling, 3D data, utility and transportation data, GPS coordinates, survey measurements, and several others. These are commonly used for commercial applications. As a civil engineer, I find geodatabases particularly interesting. When constructing new buildings, we often need to store multiple types of information for specific points. Say, for example, the picture below depicts a construction site, and the 4 stars indicate the locations at which soil samples will be taken. We'll first need to store the locations of these borings as X, Y, and Z coordinates. Using a geodatabase, we can store the site location as a GPS coordinate, the soil type characteristics, and even the date and time of the samples taken, along with other types of information that may be applicable. There are several other advantages to using geodatabases. One is that you can easily import data into a geodatabase. This is particularly useful when considering construction or surveying applications. Multiple data types can be stored at one location, as seen in the previous example. Another advantage is that you can connect points mathematically. In traditional databases, arcs are simulated by plotting multiple points and connecting these points with straight lines. But in geodatabases, these arcs can be programmed with mathematical equations, giving these natural curves. Geodatabases can also be used directly with online map server software, such as Google's Mapping API. This would allow the user to directly tie in their data with existing maps already created. Geodatabases provide us with the ability to leverage data relationships, enforce data integrity, and create intelligent features in our database management system. The picture on the right shows several types of data that can be incorporated within the database management system. People using the same geodatabase at the same time at different locations can use and edit the same data set and have it synchronized across the geodatabases. An example of this is the federal, state, and regional governments. Geographic data can be collected at each regional government and passed up to the state, up to the federal, creating a complete map of the United States. I thank you for watching my presentation on geodatabases, and I hope you enjoyed watching it as much as I did making it. Thank you.